Welcome back, everyone. Mr. Crawford here. Today I'm talking about Integrated Math 3's practice number 4. The classwork, we talked about how quadratic functions occur when x squared is present in the equation and that their graph makes a shape known as a parabola. So anytime you see something like this, y equals 4x squared minus 2x plus 9, any combination of it, anytime you see this x squared, you know you're talking about a quadratic function. If you were to graph it, it makes a parabola. The parabola may open upwards or downwards. This one. There are three forms in which a quadratic function can be written: standard form, vertex form, and factored form. Here they are. Standard form is much like the one I wrote just a moment ago. You got y equals ax squared plus bx plus c. Notice there's no parentheses anywhere, as there is none in this one. Vertex form, however, is written with a parentheses and a power of 2 on it. A, H, and K can be any numbers in the world, just like A, B, and C, and standard form can be any numbers in the world. Factored form is actually two sets of parentheses after one of these has been factored. X and X, we're just going to call these any numbers. C and D, they could be anything. So a parabola will open upwards if its a value is something positive. So notice in standard form, the a value is the number in front of x squared. Whatever number that is, if it's positive, that means your parabola is going to open upwards. If it's negative, your parabola is going to open downwards. The same is true when it's written in vertex form. So the one I wrote earlier, notice how the a value is positive 4. This would produce a parabola that opens upward. The y-intercept is the c value. Notice in standard form there's a c, a number at the back that has no x with it. Whatever number that is, that tells you where this is going to cross the y-axis. So like if I had y equals 2x squared plus 6x minus 3, that's telling me that the parabola would hit the y-axis down here at negative 3. Go right through there somewhere. All right? So the c value is your y-intercept. If you need to solve for the vertex of the parabola, and remember a vertex is either the very bottom, that point, or if it's going downward, the very top. If you need to know the exact location and they've given you an equation in standard form, like this, where we can see a, b, and c, we want to use this formula, x equals negative b over 2a. We need to plug in for both b and a. Where do we get those from? Again, standard form, the number in front of x squared is a, the number in front of x is b, the number without an x is c. So in this one, a is the number positive 2, b is negative 4, and c is 6. For this formula, however, we don't need c, we just need a and b. The top wants us to put b in. B is negative 4, so it goes in here. Keep in mind there's a negative that's in the formula, and there was a negative that came with the 4, so this gives me back-to-back negatives here, which happens sometimes. Down here I'm plugging in for a happens to be a positive 2. Back-to-back negatives, or a negative times a negative, turns that into positive 4 at the top. 2 times 2 at the bottom is also positive 4, and 4 divided by 4 equals 1. Now that's not the entire answer. A vertex is a location that needs an x and a y, and all we've done with this formula is find out what the x is. 1. We now need to take that x we just found, 1, and go back to the equation and plug it in for x here and here to find out what the y value is. So 2x squared minus 4x plus 6, I'm going to plug in for x now and solve. What am I plugging in for x? The number 1 that we just found. If you have a calculator, you can do all this pretty quickly. I'm going to go ahead and go through it. 1 squared is 1, 2 times 1 is 2, negative 4 times 1 is negative 4, and 2 minus 4 plus 6 would end up being a positive 4. So the vertex is located at 1, 4. How do you solve for the vertex when the parabola is written in vertex form? Well, you actually don't have to do any math. You just have to notice these two numbers, h and k. The vertex is h and k. So inside the parentheses, and I can see I left off my power of 2 here. Sorry about that. It's always the opposite of whatever this number is. So if this is negative 2, we're coming down here and putting positive 2. And then it's always exactly what this number is. So that's positive 4. We end up with 4. So that's where you locate the vertex from. H and K in vertex form is this number, like so. Flipping to the back side, if you want to solve for the x-intercepts, when it's written in factored form, again, you don't need any mathematics here. You just need to know what you're looking for. Take the opposite of what it is in the first binomial. X plus 3, we're going to call that negative 3. And since it's on the x-axis, it's an x-intercept, we call it negative 3, 0. The opposite of this one would be positive 4, so 4, 0. This is telling me that this parabola will hit the x-axis at negative 3, which is 3 to the left, as well as positive 4, which is 4 to the right. So it probably looks something like this. Right? Cool. In the homework, we're going to take that information and provide ourselves a sketch by just answering some questions. Starting with, would this parabola open upward or downward? What tells you whether it opens upward or downward? The A value. If it's positive, it's going to open up. If it's negative, it's going to open down. So what is the A value of number 1? Well, I don't see a number written in front of x squared, which is where you get your A from, which tells me that that number is actually a positive 1. Because it's a positive number, this is opening up. The vertex, because this is written in standard form, I'm going to have to use that formula, x equals negative b over 2a. Plugging in for b and for a. B in this case is a positive 4. A in this case is a positive 1. You'll end up with negative 4 over 2 or negative 2. Now we're going to take negative 2, plug it into the equation, where it's x squared plus 4x plus 3. Let's stick in negative 2 for x. Negative 2 squared is 4. Positive 4 times negative 2 is negative 8, and then plus 3. So 4 minus 8 plus 3. 4 minus 8 is negative 4, plus 3 is negative 1. So I know it's opening upward. I know where the vertex is. Negative 2, negative 1. On my graph, negative 2, negative 1 is to the left 2 and down 1. Because it opens upward, I'm going to go ahead and sketch that. Something like that, right? You can even be more specific if you notice that the back number, C, positive 3, tells you where it hits the y-axis, which is actually about right there. So I really jacked that up. I should have cut that much sharper like that. But as long as you give me a decent sketch based on up or down in the vertex, we're going to be good on the quiz. Next up, up or down, the A value in this case, remember in vertex form, A is written in front of the parentheses. We can see that parentheses here, that number in front, negative 4, because that number is negative, this guy's going down. To find the vertex, I don't need any math. The opposite of what's in here, exactly what's out here. So 3, negative 3. That's located to the right 3 and down 3. And this is opening downward. It looks something like that. Up or down? Well, because it's x times x, which is x squared, or a positive 1x squared, this guy's going up. The x-intercepts are the opposite of each of these. Negative 1 would produce 1, 0. Negative 5 would produce 5, 0. We'll come over here, 1, 0, to the right 1, 5, 0, to the right 5. Opens upward, like so. Last one, this is vertex form, up or down. This guy's opening up because the A value in front of that parentheses is a positive number. The vertex is the opposite of what's in here, negative 1, and exactly what's out here. A moment ago, we actually had a number out there, negative 3. This time there is no number out there, which tells me that's 0. So negative 1, 0. Go to the left 1, stop. Opens upward. So it looks something like this. All right. Hope that helps. Catch you next class.